Hello everyone. In this video, we are going to cover the topic cyclic quadrilaterals. So it's written there, cyclic quadrilateral is a special type of quadrilateral in which all the vertices of the quadrilateral lie on the circumference of a circle. In other words, if you draw a quadrilateral and then find a circle that passes through all four vertices of that quadrilateral, then that quadrilateral is called cyclic quadrilateral. So let me define you geometrically this thing. Suppose this one is the circle. Okay, and if I make any quadrilateral like that, okay, and let us say its name is A, B, C, and D. So the quadrilateral ABCD is cyclic if the points A, B, C, and D all lies on this boundary of circle. Okay, so that's the definition for cyclic quadrilateral. Okay, so if all the points of a boundary of circle, then we can say this one is the cyclic quadrilateral. Now there are theorems as well. So first one is that the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. So first of all, let me draw a cyclic quadrilateral. This one is the circle, and in quadrilateral we have four sides. Suppose this one is the cyclic quadrilaterals, which vertices are A, B, C, and D. Okay, and let us say this angle is angle A, and this one is angle B, this one is angle C, and this one is angle D. Then according to this theorem, it's given that angle A plus angle C is equal to 180 degree, and angle B plus angle D is equal to 180 degree, which means the sum of either pair of opposite angles, like this pair, angle D and angle B are opposite pair. So their sum will be 180 degree, and same applies for this one. Okay. So that's all for the theorem 1. Now after that we have, if the sum of a pair of opposite angles of a quadrilateral is 180, then the quadrilateral is cyclic. Okay, that's the reverse theorem of the previous one. So let me explain this one also. This one is the circle, and let me draw a cyclic quadrilateral like that. Suppose this quadrilateral is P, Q, R, and S. This one is angle P, this one is angle Q, that's the angle R, and that's the angle S. And it's given that the opposite pair of angles has some 180 degree, then the quadrilateral is cyclic, which means if angle P plus angle R is equal to 180 degree, or we have angle Q plus angle S is equal to 180 degree, then we can directly say PQRS is cyclic quadrilateral. Okay, that's for this theorem number 2. Now at the last of this video, we have one question also. So it's given that in the figure below, ABCD is the cyclic quadrilateral. Okay, this one, in which AC and BD are its diagonal, which means the AC is diagonal and BD is diagonal of ABCD. If if angle DBC is equal to 55 degree, which means angle DBC this one. So let me draw this one clearly. Angle dbc is equal to 55 degree, at angle bac is equal to 45, so bac is this one. This angle is equal to 45 degree. Now we have to find angle bcd. Okay, we have to find this angle bcd. Now we will start the solution like that. Okay, we will use the properties we have done yet. Okay, now in the cyclic quadrilateral, we know that opposite angle has sum is equal to 180 degree. So if we found this angle, the complete angle A, then we can say angle A or angle BAD plus angle BCD is equal to 180 degree. Okay, and if we know BAD, then using that point we can find this angle BCD. Okay, then we can find angle BCD. So first of all, we have to use the things. So as we know, angles subtended by the chord at any points are equal, which means suppose BC is any chord, then angle BAC will be is equal to angle BDC. Okay, and angle BAC is equal to 45, so we can say it is also 45. Okay, BAC is this one and BDC is this one angle, that. So I can write there also this angle is equal to 45 degree. Okay, now look into the chord CD, this one. Now in the chord CD, CD is also a chord. So angles subtended by the chord CD, which are angle CAD and angle DBC, both should be equal. So we can write angle CAD is equal to angle DBC and both are equal to 55 degree. Okay, so we found that this angle CAD will be is equal to 55 degree. Okay, now we know, now see there, but which is the angle BAD? It's the sum of the complete angle BAD is sum of angle BAC and DAC. So can I write is equal to angle BAC plus angle CAD, and angle BAC is equal to 45 degree, we have found there, and angle CAD is equal to 55 degree, and 45 plus 55 is equal to 100. So angle BAD is equal to 100 degree. Now if we put this value in this equation, okay, then we will get 100 plus angle BCD is equal to 180 degree, and angle BCD is equal to 180 minus 100, which is equal to 80 degree. So our answer for this one angle BCD will be 80 degree. Okay, so that's the answer. We can say angle BCD is equal to 80 degree. So in such a way, by using the properties we have learned or the theorem, we can find the angles like that. Okay, and that's the very common question which we got in the exams. So that's all for this video and for this chapter as well. Still, if you got any doubt, then you can ask me through my Urban Pro profile. So thanks for attending this video. Bye.